the next generation cross-chain technology. It's the first world two-layer cross-chain technology, Unitary Inter-Chain Network Protocol. The original idea of UINP comes from physics, where parallel reality can jump from one reality to the other through a tunnel named wormhole. And we found the fact, no matter what kind of blockchain network it is, they all share the same internet infrastructure. So we decided to build a tunnel inside the internet infrastructure and make the transactions from the up layer possible. This is a tunnel. UINP is a two-layer protocol. The tunnel resides in transport layer, and the observer resides in the application layer. Okay, what can UINP do? Before we understand this question, let's first discuss the assets in a blockchain network. Let's define two concepts. We define basic chain tokens, such as the Ether for Ethereum, Bitcoin for Bitcoin network, EOS for EOS network as prevalence. We define accumulated assets as some complex on-chain data, such as smart contract and other complex on-chain data. Then UINP can do 4 types of transactions. Let me make an example to introduce these 4 types of transactions. For example, if Ethereum network and Bitcoin network has some nodes installed UINP plugin, then the 4 types of transactions can happen. The first type is prevalence to prevalence. For example, you can exchange Ethereum and Ethereum coin to Ether to Bitcoin without going to a centralized digital currency exchange. Accumulated assets to accumulated assets. For example, you can exchange cryptocurrency to EOS RAM. The third type is prevalence to accumulated assets. You can use Bitcoin to trigger EOS RAM. The fourth type is accumulated assets to prevalence. For example, you can liquidate cryptocurrency to Bitcoin. Okay, the question is, how does UINP work? As I said before, UINP is 2-layer protocols. The root chain in the transport layer is a protocol that in charge of translate, locate, and the application layer observer is in charge of information format transfer. For example, we use an algorithm called binary translation to do Ether to Bitcoin translation. Let's dig into router and observer deeper. As we all know, that a traditional TCP/IP protocol stack, if you want to find a program in certain device, for example, if you want to find Uber in your mobile phone, you need to know the address and the port number of your Uber program. The combination of IP address and port number is called a socket. In UINP transport layer protocol, we're recording the addressing system of transport layer. We add perception hash to the sockets to make it a contract. Therefore, nodes in one network can easily find nodes in another network. For the observer, it's in charge of translation among sharding nodes. Here, I'm going to introduce an example to illustrate sharding network. For example, if Ethereum and EOS network have some nodes installed UINP plugin, which have the transport layer and observer layer and the application layer protocol, then it becomes to unitary nodes. And if a network have unitary nodes, then it becomes possible to recognize cross-chain transactions from one network to the other. And if this process happens, the two networks can communicate with each other by the algorithm we call binary translation. UINP consensus is named Proof United, which is a three-tier consensus system. Proof for entry is the first tier where nodes paying security deposits to participate to become a unitary node. And the reward for information forwarding, information forwarding income. The second tier is proof of verification. Nodes in this tier are going to verify all the transactions happening between different chains. And the reward for transactions verification. The third tier is Parliament nodes group. We use random deposits to eliminate the centralized characteristic of deposits. Nodes in this tier in charge of perimeter adjustment and reward for commitment jobs. Okay, let's dig into Parliament. For Parliament, it's in charge of monitoring the health condition of network, such as atomic clock, computing power, and network payload. Secondly, Parliament can forecast the next period parameters, such as workload requirement and the node increment. Thirdly, Parliament is in charge of adjust the various parameters to recover the network according to the forecast. For example, in UINP network, we have an economical system and a financial system stabilized by the two-tier adjustment. For machine part, we use a GATCH module to monitor, forecast, and adjust the income standard for all the nodes inside the unitary network. And the inflation index, which decides the best cycle interest rate for the salary nodes can get. And for the other situation, economic parameters can be changed by different module to adjust according to the situation. However, there are some situations that machine loses control. The human adjustment works. For example, external economic emergencies happen. The Parliament nodes can vote the policy to determine the strategy to face these external economical emergencies.